All right, it's a pleasure to be here and to kick this off. I hope I will have some slides. Good. I don't think there's ever been an era in human history where a new field of technology has arisen where there was so much hype and hysteria around it. I think maybe electrical engineering came close, electrons were gonna set fire to the world and all. It's amazing to me that data and inference and connections and all that is leading to such hype and hysteria. So I think one of the reasons for that is because we have some technology that's developed, but we also don't have a really good vision of what to use it for. The visions we have are the ones from the 1950s. We haven't updated. The ones from the 1950s, that was McCarthy really imitating a human. How can a computer imitate a human? And there was cybernetics, how do we kind of imitate animals who can, do all these amazing things, climb through trees and stuff like that. That's it. That's our visions. And now we're debating about the implications for that, are there business models behind that, and so on and so forth. All right, so on this slide, I'm going to propose something which is different, and that word collectivist hopefully will intrigue you what I mean by that. Let me just say up front, it kind of means microeconomics. And whenever we hear all these fields that are involved and all that, we never hear the word economics. So I hope there's some economists in the room because you guys got to stand up. It's time to have a role here. That's what's missing. Okay, so here's your standard prehistory that you will see. Here's how it all came about, which is I don't believe, but I'm going to put it up there anyway. Phrase AI was coined in Dartmouth, 1956. They didn't really know what they meant by intelligence, so they didn't define it, but it was something that humans do. All right? Focus was on a single intelligent entity, be that like a human-like entity or a program, but it was this one thing that did this amazing stuff. How do you do that? Now, I don't want to dismiss the excitement of posing such a question and the importance of posing it, the philosophical implications and so on, but it's not really what happened in technology. It's not the case that that event triggered a wave of technological development that we're now seeing. Okay? Mostly that triggered programming languages, operating systems. It did a lot for computer science, and it kind of failed mostly otherwise in terms of its goals. What happened in the meantime is this field called machine learning arose, mostly not in AI, mostly not with AI people, mostly operations research, statisticians, control theorists, signal processors, and so on. And gradient-based algorithms emerged, and eventually it became all focused on scalability and started to work. Dave Brummelhart there was my advisor. He was one of the developers of backpropagation. He reinvented it, but then he showed it really worked. And his name gets often missed in a lot of these discussions. He should have gotten the Nobel Prize, frankly, because he's the one who made it really happen. And he died young of Pick's disease. It was very sad. The other person I have up there is Leo Breiman, who did random forests. And random forests were a highly scalable architecture, different from neural nets, but had their advantages and disadvantages, gradient-based. They powered Amazon's logistics chains models, which made Amazon into a company that, went everywhere. And they powered many other companies around 1990 through 2000. Okay, so ML deployments were just these big, large bags of data and gradients and architectural stuff. There was no talk of AI. There was no agent. There was no, intelligent. It was just doing stuff. It was engineering, and it really had a huge impact on the world, huge productivity. A lot of companies were based on machine learning starting around 2000. Every company by 2010 was using machine learning in one way or another. No one was calling it AI. Okay, so then came LLMs. Oh my God. It's the same architect, it's bigger, more stuff. It's human language that's coming off the internet, and it looks human, so the phrase AI got retrieved and promoted. And that's led to all this hype and hysteria, the damn phrase AI. If we'd kept calling it machine learning, it would have been a much more sober conversation about what's the business model for that? How do you build it? How do you scale it? How do you make sure it's safe, and so on? All right, now I don't think that LLMs are like the old dream. It's not a single entity, really, an LLM. Okay, it's bringing data from all humans all across the planet. It's like a lot of little experts that kind of respond to little pieces of things. And if a couple of experts agree on something, they thought about it the same way, the machine kind of finds that and uses that as an abstraction. It's all of humanity in there, okay? It's not an intelligent entity sitting on a hill. Okay, now, so the word collective already comes up. LLMs, to me, are a collective entity, all right? But now if we're going to use the word collectives, let's recognize that collectives is a much bigger word than just bringing together lots of information. Collectives start to open up the door towards economic behavior. Humans, when we come together in collectives, we create markets, we create cultures. We create all kinds of things that just collections of data and nodes in a graph do not do. And that's what I want to focus on today. All right, and so we talk a lot about society and social science, and often in ethics, the words are just thrown out there as buzzwords, that we should be more attentive to this society and all that. Economics is a field which is not just buzzwords. It's got real principles about how entities interact to lead to value to everybody, and we're not talking that language. Okay, so more concretely, the dialogue on LLMs to me is missing some fundamental things. There's no focus on collectives whatsoever. It's all about who can build the biggest machine. There's no focus on certainty, or very bad focus on uncertainty. And there's no focus on incentives. Why should people want to play this game? Why should they want to be involved in this whole thing? Just because they're being told to by their boss? And these three things are linked. Okay, so microeconomics talks about all three of them and links them in interesting ways. Now, microeconomics does not solve all the problems. It's got to be refurbished, brought out from its origins, and made more data aware, more learning aware, and so on. It's a huge intellectual agenda for the next 10, 20 years, to me, in doing that. It's a complementary kind of intelligence. When you create a market with a collective, you don't create it. No person designed it. It emerges, and it's happened throughout history all the time. Very interesting, different kind of markets have arisen in very many different kinds of things. That market is an intelligent entity. It brings food into the city of Paris every day, the right amount, not too much, not too little, if it's raining or shining, and whatever the size of Paris over the years. You know, Zola wrote about les Halles, where, you know, the food that comes into Paris and the whole machine that does that. That's an intelligent entity. Now, when you say the phrase AGI, which I particularly hate, is that market a form of AGI? Well, no one talks that language. They seem to apply that AGI is everything, but it doesn't seem to have anything to do with markets, so I don't get it. As you can see, I have opinions. I'm old. Okay, now uncertainty. We have a bunch of statisticians in the room. I really am a statistician, just to say, number one. That's, to me, the mother field. That's where it all, how do we know what's in the world? Okay, statistics. All right, if you ask ChatGPT, how sure are you about what you just wrote, it will say something, and I think I've tried it a bunch of times. It'll say, yeah, I'm very, very sure, and here's why, and blah, 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 blah. And you'll say, but wait a minute, there's this other way to think, and it'll say, oh yeah, that's right, and it changes its mind completely. Now it's very sure about something else, all right? It's almost always very, very sure. Okay, it's not doing uncertainty, reasoning, quantification at all. What it's doing is taking some stuff from the past where someone asked, how sure are you? And there was a response, and it's kind of using that. All right? You would not want a doctor that once they give you a diagnosis, and then you say, but what about this? They change completely their opinion. Okay? It's not doing uncertainty. Now, uncertainty goes together with markets. All right? And so we want to kind of think about this. So how do we cope? How do humans cope with uncertainty? I'm running out. I need a little water. I worked very hard to get that picture, but I want to let you have a moment to stare at that picture. Okay, so what's going to happen in the future? We don't know, and it's really amazing how much uncertainty there is in our lives. Really amazing. We are not just sitting there reasoning our way through like math problems. We are living in the world of uncertainty. I don't know what's going to happen to me later today, tomorrow, next year. There's all kinds of things. But we do well somehow. All right, now in statistics, we know how to talk about some amount of uncertainty. You know, you've got that data that implies that there's this, you know, error bar and so on and so forth. But uncertainty is much broader than that. Uncertainty has to do with what you know that I don't know, and how much, you know, when we're in groups of people, where is the uncertainty? It also has to do with provenance. Did that data point come from yesterday or last year or 10 years ago? If it came from 10 years ago, there should be more uncertainty from the timing of the data. There's all kinds of issues and uncertainty. There will be a talk, a plenary by Manuel Candes later this morning. He is, like me, a statistician, very interested in uncertainty, and I'd encourage you to attend that talk. Now, I would argue that individual humans are not so good at coping with uncertainty just by themselves. You put us on a desert island, we kind of make a mess of things. But when you put us in collectives, right, we're really good. And so if I don't know how long it takes to get from here to INRIA, which is on Rue Barreau, I can ask, let's see, Eric Moulin. He knows. He used to work there. So I ask him, and I get a good estimate. We do this all the time among each other. We don't know something, we ask somebody, they give us an answer. We can tell by the way they answer the question how sure they are. We infer things. We build cultures that mitigate uncertainty. It's one of the things we do really, really well, so that we can start to build and plan and feel good. All right, so collectives are really important. Now, collectives also provide context by what we mean by uncertainty. Here's a duck who's a statistician. The duck has gotten a very good estimate that on the left side of this lake, there's a certain amount of food to be had. On average, that amount of food. And on the right, maybe a little less, okay? And the duck has got nice quantified conformal prediction error bars on this, and then, duck is kind of ready to make a decision now. So should the duck go to the left side of the lake today or to the right side of the lake? All right? Well, the optimal Bayesian decision, so the Bayesian duck would go left. All right, because there's more food to be had there. The Bayesian duck says, where do I maximize my utility? Well, it's to go left. All right? Now, if you do experiments with this, ducks don't do that. Ducks are not Bayesian. Ducks probability match. They see, oh, I see there's 2/3 as much food on the left as 1/3 on the right. Therefore, what I'm going to do is 2/3 of the time I'm going to go to the left and 1/3 of the time I'll go to the right. That's not optimal from a Bayesian point of view. I can prove that. Right, but they do it. Moreover, humans aren't Bayesian either. They probability match. And there's been tons of articles in cognitive science about how humans are terrible decision makers because they're not Bayesian. Okay? But the framing is wrong here. Okay? What if there are many ducks? Okay? What if there's a collective of ducks? Right? Now, that's a different problem. It's more of an economics problem. What should any individual duck do? All right, well, I could have a top-down regulatory government framework that says that 2/3 of the ducks should go there and 1/3 should go there, and everybody will be happy, and that's probably what's going to happen in Europe. Or I could just have a little algorithm where each duck randomly decides with probability 2/3 to go there and 1/3 to go there. Distributed, decentralized algorithm, chaos will ensue, right? No, it's a Nash equilibrium. It'll be highest maximal social welfare. So it's actually optimal to probability match in a situation like this. So the collective also determines what do you mean by uncertainty and what do you mean by decision making. So if we don't talk about collectives, we're missing out altogether on this stuff. If you put a LLM there who's making an optimal quote unquote decision based on uncertainty, you got to say, wait a minute, what's the context? Okay. So I want to start thinking about a vision of, let's call it AI, which I hate to do, but I'll do it because Jan LeCun's in the room. Sorry, Jan, I like to tease him. I want to have one where information flows between entities of a collective. Now, I don't want just this kind of notion of a graph where I have a node and there's a certain amount of data there and it flows. It's just like Internet of Things or something. I want to recognize that these entities possess knowledge and they may or may not want to share it. They may have competitive advantage. I want to think more about these as asymmetries and information flows in an economic setting, okay? So asymmetries of information are critical in economics. If I'm working with someone, why am I working with them? Well, they know how to do something I don't know how to do, all right? And so they know something I don't know. And so if we start talking about how we get a price, how much money will I give you? Well, I don't know enough to tell them the best price because they know something I don't know. They're not going to just tell me, they'll lie. So economics is full of mechanisms that allow you to make progress in that situation where everybody gets something good out of it. Okay, that's called asymmetry of information. To me, that's another kind of uncertainty. Okay, if I'm working with you and you know something I don't know, I'm uncertain about something. And that's not statistical uncertainty. That's not going to go away at the rate 1 over square root of n. Okay, all right, so these things are all linked up. We want to use our technology now, this burgeoning technology, not just to build LLMs on a hill with all this power usage, but we want to connect people. And we want to connect people with machines. And we want to connect things that give value to people and to entities. All right? But if we just connect things, we'll do what Facebook did. We'll connect things and make us a mess. Sorry again, Jan, but nonetheless, I got to say that. Right? Why do people want to connect? And what prevents them from lying? Well, nothing prevents from them lying. I think there's some lying going on Facebook. I'm not sure about this, but I think there's a little bit of lying going on. Okay? So we need something more sophisticated than just connect things up and make predictions. We need some more statistics, and we need some more economics. All right, so just one last slide on kind of, provocative statements here. But here's what I think Sam Altman has in mind, or Elon Musk or whatever, is I take all of humanity's knowledge that they're producing on the internet that I just take for free, grab it, and I create this super AGI thing that can answer any question. It knows everything, right? And so humanity's saved because we can ask about how do I solve climate change, or how do I get to the Rubao very fast, or whatever question I want, and it'll tell me. Now, we'll spend a huge billions and trillions of dollars to get that thing, but once we have it, we've saved humanity. All right, this is nonsense. This is nonsense. I don't want something up there telling me what to do. It doesn't know my current situation, doesn't know my current context, doesn't know what I might want in the moment. I want to be like in a market where I get to kind of look around and think and interact and be a human being. And I want these machines to be in the market too, because they'll know some things I don't know. I'll be happy to interact with machines, but they got to kind of talk some of my language, uncertainty, information, asymmetries, and so on and so forth. So I want it all embedded in there. Okay? So I really think this model of, build the biggest thing on the hill that knows everything is not feasible. It's going to ruin us. And second, it can't know everything. Because what's in my mind right now is the context of what I'm going to do next today in life. It cannot know that. And if it doesn't know that, it can't give me good advice. And I think it's this advertising model where these companies thought they could know everything because they've seen our entire browsing history. And they could predict really, really well. And therefore, let's build AI that just predicts, and it'll tell us what to do. Okay. All right, so I want to do something different. So I want more of an economics model, and I want to do that in the context of markets. So to me, markets are a good word. In some environments, markets are viewed as capitalists. I've kind of gotten questions about, wait a minute, don't markets ruin the world? What are you trying to do here? I think markets are good. Well, they've arisen throughout history, many cultures, many times. They're how humans interact. They reduce uncertainty. So just like Zola talked about, the market that brings food into Paris, somehow someone says, I got some tomatoes. Over there are not enough tomatoes. I'm going to take my tomatoes over there, charge maybe a little higher price, and tomatoes will be available. Everybody does something like that every day. And now I can guarantee there'll be tomatoes most days in most places. Why is that good? Well, because if I'm a pizza owner now, I can have a pizzeria because I can guarantee I can find them tomatoes any day of the week. All right? And then if I can have a pizzeria, I can have something else on top of that. I can have something else on that. Things can emerge if you can build stability. Uncertainty is mitigated by markets. All right? Prediction becomes easier when you have markets. All right? Now, markets have to be regulated. So this is the obvious question. Oh, you like markets? That's great. But don't they, spin out of control? Don't you get monopolies and all? Well, yeah, sometimes monopolies are good, actually, not so necessarily. But, things can spin out of control, and they do. So you want to regulate them. I'm a total, yes, we need to regulate them. But you don't regulate the individual algorithm, the individual mechanism. You will create unintended consequences, no doubt about it. You regulate the equilibria of the system. And to find the equilibria, you've got to be more like an economist and study what are the equilibria and how do they change. So I'm going to give examples of that. Okay, so I've been involved in a company for about 10 years now called United Masters. The CEO is a friend of mine, Steve Stout down there. He's a legendary hip-hop producer in the United States. Everyone knows him. And this is a three-way market. So you don't usually study three-way matching market. You don't really study this in economics very much, but so what it is that there are lots of young people, 16 to 25-year-olds, who create music on their laptops, and they're really good at it. And they put it up on the internet, and that's the music that other young kids listen to. So 90% of the songs that are being listened to every day, at least in the US, 90% are songs you never heard of, the artists you've never heard of, and they were written in the last 6 months. So it sounds like great, a thriving market exists. No, they're not making any money. No money is being exchanged. Everybody takes everything for free. And a few big companies find a way to make some money off of subscriptions. All right, so this is a different model. What it does is we've got musicians here who are making music. We've got listeners sitting over there as another side, leg of the triangle. And now critically, there are brands involved here. Brands have money and they have goals. All right, so in particular, the NBA has signed on with United Masters. What's that mean? If you go to the NBA website and you watch a little clip, often there's music behind it, okay? And it used to be that the NBA paid Beyonce or whatever a vast sum of money for that music. Now they go to the United Masters and they say, give me some music. United Masters is a very good recommendation system. They can say, oh, for that kind of purpose, that kind of audience and demographic, here's a good kind of music. They stream it. The musician gets paid in that moment. All right? Then there's other brands involved as well. They watch all of this, it's an open market, and they say, oh, that artist seems to be popular on the NBA website. That's my demographic. I'm going to reach out to that artist and work with them too. This has been now happening for 5 years. There are 3 million musicians who are making money off of this platform right now. Okay, this is an up and running company that is really, really working. And it is getting people paid for creative acts. All right? And it's critical that it's a 3-way market. If it's a 2-way market, you got something more like Spotify, which is that some artists make some music, it gets streamed out there, and where's the money come from? There are no brands, there's no one willing to pay anything. Well, okay, I'll try to make a little money with subscriptions and I'll throw a little bit of change back at these few artists. But it's not a real market, okay? And so that doesn't work, and moreover, that incentivizes Spotify to get rid of those artists. Why don't I put Gen AI in there to make the music? Because I can get that for free. It incentivizes that kind of activity. It's damaging to the human species. 3-way markets actually really help. They are a good platform for starting to build this. Now, where's the AI in all that? Well, you know, behind the scenes, so I was involved in this, in designing this system. There's a great deal of data flow. It's a matching market with adaptive, you know, who listened to what and what kind of music is it. There's also market design principles. There's mechanism design here. Okay? There's contract theory and mechanism design brought together with machine learning, and it just works. All right. I think there's lots of companies that you could do this throughout the world. It's not being done in Europe that I'm aware of. You could do this with print journalism and not just music or in other kinds of art. There's all kinds of new markets which you can start to think about creating if you think about AI in this way, instead of put all the knowledge in a big super AGI and somehow money is a consideration only for the wealthy. All right, let me just say, I really want to emphasize this. Money is going to 16-year-olds here who do have a creative act. And that money is being given to them not just because some rich person just throws it at them, it's because they're being incentivized in a market to pay. There's all kinds of other markets you can start to think about if you put your mind to it that really haven't been studied in economics, but machine learning drives you to study them. So 3-layer data markets. This is work with Ali Reza Falah, postdoc with me, and who was with Asu, Ostaglar, who's here. So here's a system we were studying where there's users, platforms, and data buyers. All right, so users are people like you and me. We come in, like say to a credit card platform. We want to get a service, which is financial service. So by using the service, data flows to them. They get the data, they improve their models, and I get a better service. That's kind of nice, right? But it's often the case that those companies don't make enough money off of the service, the little fee they charge. A lot of downward pressure on that. So what they then do is take the data and they sell that to third-party buyers. This happens all the time. There's nothing wrong or weird about this. It happens all the time. Now, why do the data buyers buy the data? They're not trying to compete with building better models, compete with the platforms. What they want is to use the data to do like market research. You know, I want to have a new Thai restaurant in the 13th arrondissement. Let's look at what kind of data, what are people talking about, what's missing for restaurants, you know, so I can buy data and learn about that. And it happens all the time. All right, now, you've got to say though, but what are the users, don't the users have a little concern about this? They're losing privacy. Their data is getting shipped off to some anonymous third-party buyer. They've lost something. Maybe they don't want to play this game. Why should they do it? Okay, and that's a perfectly good question. You can't just assume they're going to do it. So we got to think about the incentives. All right, and so here's the way to think about this with Ali Reza, is that the platforms have got to give some kind of guarantee of privacy, okay? And what's that mean? Well, we have differential privacy. It's a pretty good framework. So they can do differential privacy, which adds some control about a noise to the data. And different platforms can decide how much privacy they will offer. It's part of their service. So I'm going to offer you, you work with me, I'm going to add a lot of noise to the data before I send it to the data buyer. So your privacy with differential privacy is very, very high. I look at that and say, great, I'm going to work with you. Okay? That means that that platform gets more data than the other platform. That means it can build even a better service. There's a little virtuous circle there. But the data buyer looks at that platform and says, wait a minute, you're adding a lot of noise to the data. That's crappy data. I can't do statistics with that. I'm not going to work with you. I'm going to work with this other guy. And so you can see there's trade-offs. And all you got to do as a good machine learning economist person is write down a bunch of equations that have all those trade-offs in them, write down the utilities, find the equilibria, and study the equilibria. So that's what we do in a sequence of papers, not only this one. And I decided not to, in this talk, get into the details of the equilibria. But let me just say that behind the scenes, there's something of the theory of incentives happening here. We have asymmetry of information. Somebody knows something that someone else doesn't know, how much they're willing to pay for something. And so you can't price things if you don't really know how much they're willing to pay. You kind of have to guess or run an auction. And the theory of incentives does things like business class, economy class fares. It says, I don't know how much you're willing to pay, but I'm going to give a sequence of options, and each one of them will have a different kind of service and have a different price. And then you get to choose. And everybody gets the same menu. And if I design the menu well, it'll kind of cover most of the willingness to pay. And I'll get a few people paying a lot, a few people paying less, the airplane will be full and all. And this saved the airlines in the 1980s. The airlines were about to governments were propping them up. But this contract theory came along and saved the airlines by having these different kinds of fares and so on and so forth. Okay, so this sounds interesting. This sounds like it's relevant to the problems we're talking about. So now we're going to have to talk about our nodes as being things like principals and agents. That's the language used here. The principal wants to do something. The agent knows how to do it, and they need to interact, and there's asymmetry of information. The agent knows something the principal doesn't know. So we have this uncertainty to manage in our network. All right, and there are algorithms. There's a beautiful book by Lafont and Martimore, written quite a long time ago in France, about many kinds of mechanisms that'll kind of, how do you design that menu? Now, what's missing in economics, almost always is, in microeconomics, there's no data, there's no learning. You design the system, you put it out there, and you're done. So all of statistics is not being used. There is, statistics means economics, that's called econometrics, that's more about measuring time series and more for macroeconomics. But in microeconomics, precious little. Okay, so we modeled this. We wrote down a bunch of equations, a bunch of statistics equations, and a bunch of economics equations. Data is now a good and a service. It's not just bits on a wire. It has an economic value. And entities can be both a principal and an agent. The platforms are both principals and agents. So we have a hierarchy now of principals and agents, not just this classical principal-agent paradigm. We built a model. And I'm not going to get into the details here. And now this turns out to be what's called a generalized Stackelberg game. Just a little game theory came in. The platforms make a decision about what services, how much difference or privacy. User decides which platform. Platform decides the price to charge to the data buyer. Buyer decides where to price. Blah, 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 blah. Okay, so now you can do that mathematically, and you can get equilibria that are functions of all of the parameters, like a utility of how much I care about this, how much do I care about that. And you can make little plots of that parameter, here's the revenue, here's so on and so forth. And those are the kind of plots you could show to a government official, and they will understand them. And that's what economists do in other fields. They make little simple parameters and then the behavior. We could do that with this really complicated learning system and actually now drive regulatory thinking at the right level, which is the level of the equilibria. Okay, so we did that in this paper. We actually showed how there's trade-off between the amount of privacy you offer and the various aspects of the market behavior. And we were able to show there's a way to get higher user utility than just kind of blindly insisting that you don't send data or that you add a certain level of noise to everything. And I think the GDPR is just kind of blind. It was not designed with economic thinking in mind. And the GDPR is known to actually hurt small to medium businesses. Okay? And the mechanism we're proposing here would not. Okay? I won't say it's going to fix all problems, but it is based on economic thinking. Last little part before I finish, I'm going to dig a little bit more into contract theory. So remember airlines, business class, economy class, and so on. This is work with colleagues Stephen, Michael, and Jake. And we're going to bring statistics into economics now in a real fundamental way. So the statistics is going to bring the control of errors in an uncertain environment, and the economics is going to bring the incentives. If you put two together, you can start to solve some real problems. Here's a real problem. Clinical trials are run in every country at vast cost, millions and millions, tens of millions of euros or dollars for all these therapeutic areas. Clinical trial is that I go get 15,000 people and give them the drug, and 15,000 people don't get the drug, and I do it randomly, and then I compare and see if the drug works. It costs a lot of money to do those kind of things. If you don't do the clinical trial, you're going to do bad science and do bad medicine. All right, so we think about this. This is not the way the FDA thinks about this. FDA is the American regulatory agency. We think of this as a principal agent problem. The FDA is a principal that only has partial knowledge. Here's a new drug being proposed. I can look at that protein and say, well, maybe that'll act on this kind of, cell. Maybe that'll help. I can guess, but I don't know very much. And I'd like to decide whether it goes to market or not. So I have to do a clinical trial if I'm the FDA. All right, and what's the FDA trying to do? Well, they're trying to be a good statistician. They want to control statistical errors. False positives and false negatives. False positive is I put a bad drug on the market. That would be bad. False negatives, I failed to put a good drug on the market. That would be bad. FDA is very good at trying to control those errors. They're statisticians. But the problem is that the proposed hypotheses they're getting, here's a good protein to look at, is not just coming out of nature or out of science, it's coming from self-interested agents, which are the pharmaceutical companies. All right? And the pharmaceutical companies know things about whether the protein is likely to work or not that they don't tell the FDA. All right, so now, if the pharmaceutical company knows the FDA is using some statistical procedure to control errors, it can game the system. It can say, oh, given that procedure, I'm going to use my internal knowledge to decide that this set of proteins I'm going to go ahead and send in, because there's a chance that even if they don't really work, they'll pass the false positive barrier and they'll get onto market at least for a year or two until everybody realizes they're no good. And companies do this all the time. Okay? All right, so I have a slide here which I'm going to skip, but for want of time. But here's some numbers that show you how pharmaceutical companies can game the system. And so the top part of it is the statisticians, Neyman Pearson testing, doing it right, controlling errors. And the bottom part is the economics, which is that if a small profit is to be made, the CEO can reason in one way, and if a large profit is to be made, the CEO can reason in a different way, and she can figure out whether I should incentivize my people to send in lots of proteins or not so many. And in the one case, she will lose money if she does it wrong, so she doesn't. In the other case, she'll just make money for free because the false positive rate is low enough that she could just send things in. So you can game the system, just a long story short. And this happens all the time. There are plenty of drugs on the market which are not effective. So we have a new theory. We call it Statistical Contract Theory. Again, I won't get into details here, but I just want to show you a little algorithm. This is a contract in contract theory. An agent, which is now a pharmaceutical company, is given an opt-in protocol. If you want to send in a drug candidate, you either can walk away when you look at this protocol, or you can pay a reservation price R, like $2 million, and now you get to choose a payout function from a menu of payout functions. Payout functions are like licensing terms, how long you can do it for, what kind of strata, all the details. Now, it's like business class, economy class. I can look at that and I say, well, that one is good for me because I happen to know that my protein's actually pretty good and very likely to pass. So I'm going to take a little risk and go for those licensing terms. And some other company says, I don't know much about my protein, I'll take a different one. So we have now mechanisms for designing that menu. And I'm going to show a theorem, because this is a science conference, and I was told we could actually show a theorem. We have a theorem which says that a contract is incentive aligned, okay? Meaning that the right thing to do is to send in the good drugs, not the bad drugs. So a contract is incentive aligned if all the payoff functions are what are called E-values. If you know about P-values from statistics, those are tail probabilities under the null distribution, and E-values are non-negative super martingales under the null distribution. So it's a different way to quantify uncertainty, and it turns out if and only if. Contract theory is incentive aligned if and only if the statistics part is using non-negative super martingales. Okay, I'm going to finish with 2 slides. Okay, so here is jumping up 5 levels. Okay, my personal view on this whole AI thing is that it's not AGI, it's not finding, the secrets of human intelligence. That'll happen someday. I don't say it won't. But humans are way smarter than our machines right now, just way smarter. Okay, I mean, they're smarter in some ways. Like a computer can already calculate all the digits of pi. I can't do that, all right? But there are ways that we are smarter, and we will be for quite some time, all right? So what's really happening is there's a new engineering field emerging, like civil engineering, like electrical, like mechanical. Every 50 years, there's a new field that emerges. It's an engineering field. This engineering field, different from all the previous ones, has humans as part of the engineering thing, okay? Civil engineering, not so much. Electrical engineering, not so much. This field does. So it has human decisions and data and flows on networks. Those are the ingredients of the engineering field. And what is the goals of the engineering field? Well, to solve science problems, yeah, sort of, but also just to build good transportation systems, to bring good health care, to solve climate problems, just to make all of our 7 billion people on this planet actually have a good life. That's the goal of this engineering field. And to make education better and make it more interesting art possible, and all those great things that humans can do if they're augmented with these kind of systems. All right, so I think it's really interesting, emerging field. It builds on ideas from inference. It builds on ideas from algorithms. It builds on ideas from economics from 3 centuries, all right? But it doesn't just flow exactly from them, kind of in the way that, like, chemical engineering flows from quantum chemistry. There's a little bit more of a gap. So we're kind of making it up more as we go along. But I think this whole development of this wonderful engineering field is really being held back by this old AI aspirations. Build a super robot that takes over or helps you for all your tasks at home and all these kind of things. All right, so just last slide, that was all about kind of the, what is this technology and what's it mean for society and all that. But as academics, and I am an academic and always will be, it really is critical to recognize this isn't just computer science. Okay, I've been in the room talking about AI lots and lots of times, and even like AI and regulation. And I ask, how many people are computer scientists? Well, half are computer scientists. How many people are lawyers? The other half. How many people are economists? Nobody. All right, that's just dead wrong. And so these 3 ways of thinking, let's not even call them fields, but computer science is kind of algorithmic thinking. Statistics is inferential thinking, very different kind of thinking. And economics is incentive-based thinking. And interestingly, these fields have come together in a pairwise way over the last 20 or 30 years. Statistics meets computer science. That's exactly what machine learning is, okay, in the best version of machine learning, all right? Statistics meets computer science, that's machine learning. Machine learning doesn't have much economics in it, as I've been stressing. Statistics meets economics, that's econometrics, but that's mostly about analyzing time series and helping macroeconomists. Okay? Not much algorithmic mechanism kind of stuff in econometrics. Economics meets computer science, that's a field too. It's called algorithmic game theory. It helps design new kinds of combinatorial auctions and so on and so forth. It has no statistics in it. It doesn't learn. You don't get learning auctions, all right? And the point about it is that green place is the place to be. So if you're at a real company designing real systems that really use data and make decisions for large numbers of people, you will be in the green area. You'll be in the middle. You'll be using all these ideas in a blend. And the students in the room learn all 3 of those fields and then endeavor to work in the middle in the green area. Thank you.